Hello, this one is going to focus on solutions to linear equations. For this first question, it's a type the correct answer in each box. Use numerals instead of words. If necessary, use a slash for the fraction bars. So this says complete the equation below to create an equation with infinitely many solutions. So just to review, when we are solving equations, there's three different types of solutions they can have. We can have an equation that has one solution. So let me find another piece of paper. Give me just a second, bear with me. So if I wanted to have an equation that had one solution, that's going to be an equation that when I solve it, I end up with a variable and I end up with a number. So for example, 3x equals 24. When I go to solve this equation and I divide both sides by 3, because this is 3 times x and I want to undo that, I'm going to be left with this solution that x equals 8. What that tells me is that the only way to make this equation true, the only solution, the one solution, would be that x would have to equal 8. Because any other number I put here is not going to make a true equation. The other type would be no solution. What this would mean is that no matter what I do, I am never going to be able to get these two sides of the equation balanced. So that could be something like 5x plus 10 equals 5x minus 3. The 5x's on both sides, what you're going to notice, that's exactly the same. So when I go to take my first step and I try and move this variable over here, 5 minus 5x is 0, and 5x minus 5x is 0. So what I'm left with is this equation that says 10 equals negative 3. Well, we know that 10 does not equal negative 3. So that is never going to be true. I am never going to be able to find a number to put in this variable for x that would balance this equation. The last equation type is infinite solutions, or infinitely many solutions is what you'll sometimes see. So infinite solutions means that every number that we put in this equation will work. So if I had an equation like 4x plus 12 equals 2 parentheses 2x plus 6. When I go to solve this equation, so I'm going to distribute 2 times 2x is 4x, 2 times 6 is 12. I end up with the exact same things on both sides of this equation. I have 4x over here. I have 4x right here. I have plus 12, and I have plus 12. So what we're going to find, if I go to move this variable, and we already can see they're exactly the same. 4x minus 4x is 0. 4x minus 4x is 0. And I'm left with this equation that says 12 equals 12. That's always going to be true. Doesn't matter what number I use for x, that is never going to change that is a true statement. So those are just a quick review of the three different types of equation solutions we might have. So, infinitely many solutions. What that means is that we want these to balance out so that they are exactly the same on both sides. So we have 7x over here minus 8 equals 8 plus something x minus a number plus 3x. So looking on this right hand side, and I'm not going to do that. On the left hand side, I have 7x's. Over here, I only have 3 so far. So in order to make those equal, I need 4 more. So right here in front of this x, I'm going to put a 4. 4x plus 3x gets us our 7x. So those two would now cancel out. This next piece we have right here is a -8. On the right-hand side so far, you can draw a line down your equal sign if that helps you. We have a +8 right here. Okay, if I cover up everything else, that is a +8 right now. So what we need to do is we need to figure out what I can subtract off to get that all the way down to -8. So 8 minus 16 gets us down to -8. So what I could see now, if I wanted to simplify this to solve it, my right side or my left side is already solved, simplified. So I have 8 minus 16, that's -8. I have 4x plus 3x, which is 7x. That equation is now exactly the same on both sides, which means that it is always going to be true. All right, looking down at question 2, which of the following best describes the solution to the equation below? So we have 4x plus 13 equals 4x plus 23. Well, if I go to start solving this and I subtract 4x from both sides, 4x minus 4x is 0. 4x minus 4x is 0. And I'm left with the fact that 13 equals 23. That is never going to be true. So what that tells us is that there is no solution that will make that true. 13 is never going to equal 23. All right. Starla and Lewis are saving money every month. Starla has an initial balance of $100. She deposits $15 every month into her account. Lewis, on the other hand, has an initial balance of $65. I'm going to circle that. And he deposits $20 every month. This question asks us how many months will it be when they have this same amount of money in their account. So, what we want to look at, this says Starla and Lewis will have the same balance in their account every month. Starla and Lewis will never have the same amount. They'll have the same amount after 6 months, or they'll have the same after 7 months. So, a couple ways we could solve this. We could write an equation and solve it. You could create a table. You could download an app called Graphing Calculator. It's free. And you could actually graph these equations and see it on a graph as well. What I'm going to do is show you how to do it solving an equation, which means we have to write an equation first. So what we're going to do, and I'm going to do it down here so I got a little bit of room. We're going to write an equation for Starla, and it tells us that she starts with $100, so I'm just going to put $100. Plus, she puts $15 in there every single month. So 15 times X. Every single month, she puts $15 in there. Lewis, on the other hand, so equals, starts with $65, and he puts in $20 per month. So every single month, Lewis puts in $20. So what we're going to do now is we're going to actually solve this equation. So again, you can draw your line down your equal sign if that helps you. I'm going to take off this 15x because we want to get all of our variables to the same side. And move it over there. Notice I subtracted on both sides. We have to do the same math on both sides or else your equations are going to become unbalanced. 15x minus 15x makes 0, which means I'm left with 100 on this left-hand side. I haven't touched this 65, so it's still there. 20x minus 15x means that I have 5 x's left. Don't lose that variable. A lot of you all used to lose your variables when we were solving equations in class, so be precise. The next thing I want to do is I want to move this 65 over. I don't know why I wrote a minus. That is a positive 5. 20 minus 15 is positive 5, so I apologize about that. We're going to move this 65 over with the 100. My variable is already over here, and we're going to leave it that way. So I'm going to get rid of, this is called the constant. I'm going to get rid of that. 65 minus 65 makes 0. 100 minus 65 gives us 35. And I have a 5x left over on this right-hand side. Our last step is to divide. So I'm going to divide both sides by, this is called the coefficient. 5 divided by 5 is just 1. 35 divided by 5 gives us 7. So what that tells me is that after 7 months, they are going to have the same amount of money. We could take it a step further and actually figure out how much money they would have, but the question does not ask us for that, so we are not going to worry about it. All right, question 4. Question 4 is asking us which of the following equations has no solution. So what we are looking for is equations that are going to come out and have no solution at all, which means they are not going to be the same on both sides. So we can start by solving these. So we could say 7x minus 6 equals 42x minus 6. I can subtract 7x here, subtract 7x here. There's my equal sign. 7x minus 7x is 0. So negative 6 equals 42 minus 7 gets us 35x minus 6. So I'm now going to add 6 on both sides. That's going to give us a 0 over here, which equals 35x. Now, just because there's a 0 does not mean that there's no solution. That's not what that means. So when there's a 0, we still have to finish dividing this. So 0 divided by 35 means that x would just have to equal 0. That is still a solution. A lot of you all, when we were in school, would think that because it says x is 0, that means there's no solution. That is not accurate. Okay, there is one solution, and it's when x is 0. So cross that one off because that has a solution. I'm going to skip down to C for a second. If we look at C, 7x, 7x, minus 6, minus 6. That is exactly the same on both sides. That is actually going to be a situation where every number would work. That is an infinite solution. So I'm going to cross that one off. That is infinite solutions. I'm going to pull B down here and look at it. So we have 7 parentheses x plus 6 equals 7 parentheses x plus 14. We need to do distributive property on both sides. So 7 times x is 7x. 7 times a positive 6 is 42. On the other side, 7 times x is 7x. And 7 times 14 is 98. So what we should be able to see is that both of these have 7x on both sides. So when I go to move that 7x, they are all going to cancel out because 7x minus 7x is just 0. So what I'm left with in this equation is the fact that 42 equals 98. We know that that's not true, so that is going to be our equation where there is no solution. All right, question 5, last one. Complete the equation below to create an equation with no solutions. So we do not want this to be true at all. So here's what we're going to do. We're going to solve this, simplify this left-hand side real quick. So 5 times 4x gets me 20x. 5 times positive 7 gets me 35. And I still have a minus 2x over here, so I want to make sure I write that down. Equals, and I'm just going to leave this right-hand side alone for a second. We're not going to worry about it. So, over here I have some variables that are over on this same side of this equation, but they're not together. We need to combine those. So if you had 20 x's and you took 2 of them away, you really only have 18x plus 35 equals. So what that now tells us is, looking over here at where our variable is, in order for these to cancel each other out, I need this to be the exact same number of x's as this side. So when I come over here and I look at this, we're going to want this to say 18x plus 21. Because when I go to subtract that 18x, those 18x's are going to cancel out, which is going to leave us with 35 and 21, which we know is not true. That's never going to be equal. So that is all your different solutions to linear equations. Thanks, guys.